And the IHD or
Yeah.
DU calculation gave you what? Maybe
Um,
one.
it's 2 times 7 plus 2 minus 14, right? Divided by 2. So 16 minus 14 divided by 2. Is it
Did
just
you wake
1?
up late?
What?
Did you sleep enough? Oh,
Oh no, I slept for like 4 hours. I didn't sleep at all. I got 1 for the IHD. I got up at like
so you
5.
slept late and woke up early.
No, I went to bed. I couldn't fall asleep, and then I had a
Yeah,
workout class at 7 o'clock this morning, and it's like 20 minutes away. So I
yeah.
was up at like 5. What is it?
Yeah, when you study a difficult course like this and difficult chapters for that matter, your brain gets burnt out and it takes long to sleep.
Is that why I have not been sleeping?
Yeah, that happened to me yesterday because I was doing complex stuff the whole day. So by the time I went to sleep, I was telling my wife this morning, wait, because she works night, I told her, I didn't sleep well at night. And she's like, Then I knew, oh yeah, I worked off my brain and therefore it struggled to go to sleep.
Yeah, I'm not a fan of that.
Yeah. Anyway, so I don't say that the 1 at 2.5 is a ketone. Just say that that's the alpha carbon,
Okay.
CH.
Okay.
But I
I just know.
understand what you mean. It would have been a peak at 9, 10 if you had an aldehyde.
Yeah.
IHD of 1 tells me I have one pi bond that probably IR will show me this at 1700. You'll see that signal tomorrow during the test, sorry. At 17, it's always the carbonyl. If you have an aldehyde, you expect to have the carbonyl and the twin peak, remember? Do you remember
Yeah.
the twin peak for IR at around 2700?
Yes.
That would be the hugest clue that you don't want to miss.
Okay.
If the proton NMR does not show you the peaks that you're looking for, or you can use the twin peak and the proton at 9, 10 to know it's an aldehyde. So what is this down here? Tell me.
The 1.96.
Yeah, what's the 1.96? Yeah,
Is it is it just a methyl group or a CH2? It's one or the other.
is a CH, it's not one or the other. It's 1.96 is approximately 2.
Okay, so it's a CH2 group.
Yeah, this is approximately 3. Now,
Okay.
this is the count of hydrogens. So total is how many here?
Like, wait, what do you mean?
How many protons based on integration?
Oh, 6.
Yeah, you're really fried. Your brain is fried. It's 7. 3 plus 2 plus 2 is 7. However, that's not what we have in the formula, which is why I told you this question looks challenging. I gave you a clue when we were doing NMR stuff. When this happens, what does that tell you?
Wait, I'm confused. Why is like how do I know that there's 7 H's? Because of what's next.
Integration is usually the count of hydrogens.
So it's the thing that's
2
next to
plus 2
count
plus
them?
2 plus 3 is 7, right?
Yeah.
2 plus 2 plus 3 is
Oh,
7
okay.
hydrogens.
Sorry, my professor doesn't do it down there. So like I didn't know what I was looking
Oh,
for.
okay. So you can have the count here also. It's the same information.
Okay. Okay.
Or you can have those boxes to count the steps.
Okay, got it.
Yeah. So you see how these steps have equal height?
Yeah.
So if one is a CH2, the other one has to be a CH2.
Okay.
And then this
Oh,
is like one more. So this has to be CH3. There are several ways to count the hydrogens. You can use the relative height of integration, or you can use the numbers ratio.
So is that like multiplet in in the middle, or the what is it called?
It's
Heptet?
not a multiplet. Let's see, one,
I
two, three,
think it's a
four, five, six is a sextet.
sextet. That's gonna be like our carbon chain basically of all CH2s, right? Because I know we're gonna have that.
This thing has, okay, I don't want to preempt it. I want to hear your reason because I kind of
Well, I
have.
think I already got the structure, so that's why I'm saying that.
Okay, so what is your structure?
One, two, three, four. It's a chain of 7 carbons. So what is that? Heptane
One,
with
two, three,
carbon
four,
two,
five, six,
and then I have 7 down, and then
seven,
on
then
carbon two I have a carbonyl. That's what I drew, and it
carbon two, you
matches.
have a carbonyl.
Yeah, it matches everything. So that's what I'm
That would,
assuming.
that would be wrong because this carbon right here should be a pentate, which I don't have. Also, that means I have one, two, three, four, five, six signals. I only have three signals.
Because there's no splitting.
You
So
have three signals, three chemically equivalent group of hydrogens. You don't have six of them.
what if you put it in the middle, the carbonyl? Then you get less signals because of
Yeah,
splitting.
that's why I was asking you. We have 7 hydrogen here, but we have 14. That tells me that I have symmetry.
Okay, got it.
We usually, when I see this, I tell myself I have symmetry, 7 times 2. So if there's a way to divide my molecule to have 7 hydrogens that are reflective, that's what I'll do. And this
Okay,
has to be the structure.
okay. So I was right, but had the carbonyl in the wrong spot. So
Wrong
that's what.
spot because it gives you so
Okay.
many signals, yes.
Okay.
And if you look at the carbon NMR, let's see. No, we did that. These are different one. It's a different question. If you look at the carbon NMR, you see you have
No CH group.
one, two, three, four. This is the solvent.
Isn't
So
that
if
like
you,
base?
if,
Oh wait, no, I lied. Wait,
uh,
one, two. I was gonna say something stupid. Never mind.
maybe you are thinking about depth. They did not say that this is a depth. This is just the normal one. If
Okay.
there's a depth, we'll know we will have CHS, CH2 based on whether they are upright or upside down.
Okay. Got it.
So that one, that's the answer. That's why I told you it's somehow tricky.
Yeah, because I completely like forgot about needing symmetry. I feel like we haven't really done things like that.
Okay? And that's what we bring. It becomes
Okay.
very difficult.
Yeah, I
Now,
feel like
this
that's
is under aldehydes and ketones, so at least you have an idea. Look for alpha hydrogens for sure.
yeah. I don't think he's gonna test on like a carboxylic acid because we didn't get to that part of the chapter. Like I know what it is, like I know what to look for, other than like the derivatives, because I saw like I looked ahead and I saw that that was a thing.
I'm suspecting an ester because
I
that
can get
one
an
has
S.
that oxygen that will give you a peak at around 4.
That'll come up in the aldehydes and ketones chapter.
No,
Yes.
I mean in terms of NMR.
Okay. Got it.
But I think the most likely is aldehyde and ketone for NMR. But
Okay.
if it has to show up in chapter 20, most likely an ester. Carboxylic acid is too obvious for me, unless he wants to just give it as an easy one.
I hope.
Then your I will show an ocean at around 3300.
Yeah, I'm not worried about the carboxylic acid because it's like in
Yeah.
your face. Like you know what it is.
Then the rest follows. You just use the N formula. So for example, this was a triplet. So it's a CH3 next to CH2. N is 2. This is a sextet, which is why we expect N equals to 5. We'll have, it's a CH2. So we'll have a CH3 on one side, a CH2 on the other side.
Okay.
Just remember the N, M equals to N plus 1, where M is the triplet, doublet stuff. N is number of neighboring hydrogens, and then You use that. You're gonna need it for the next one. I don't want to do that. I want to do this. Then we can do some synthesis.
Okay.
So this time you're given depth 135 and depth 90. Do you remember the rules
With
of,
what?
of how peaks will show up in depth and in depth carbon NMR?
Um, well, my professor like does it different where like the CH2s are upside down and the CH and CH3s are upward facing. Yeah, we
Yeah,
have ours like
so it should be something like this.
okay. Yeah.
So the CH3 will be up in 135. It's the only thing showing up in depth 90 is gonna be the CH.
Okay.
And then CH2 will be upside down in depth 135. The rest will be upright. That's how I memorize them.
Okay.
So I don't know why this information was given. Maybe it is important to put the structure together. But usually for me, it's rare for me to use my carbon NMR to decide.
Yeah, I never really use it.
I generally feel like proton should tell me everything.
Hmm.
Now you
Okay.
see you have peaks at 4,3. That's definitely a CH next to an oxygen. Mhm. Aldehyde, IR says that we have a peak at 1711. IHD tells you what?
Um, how many hydrogens like you're lacking? I guess.
No, what is the number after
Oh.
calculation?
10 times 2 is 20 plus 2 is 22. Is it 5? I just did mental math, so if it's wrong, like,
Mm,
it's 10 times 2 is 20 plus 2 is 22
yeah, it's
minus
5.
12.
And
Okay, yeah,
usually when you get that, most likely you have this guy
yeah.
and this because of IR. HD equals to 4, HD equals to 1, this is 5.
Okay.
It looks like we have a CH in our depth.
Wouldn't those come from the ring? CHs?
Yes, you're so right. And here you're telling me that your brain is cooked. That brain is so young and vibrant. You just
Silly
need to
for my
breathe in, breathe out, and maybe go take a yoga like you advised me, or you advised your professor.
I did advise him that, and I hope he took my advice. Um,
What is the proof for the benzene ring?
what is the what?
Prove that you have benzene ring.
Is it? Is that the one that's at 7?
Yes, and then what is the shape telling you? You have two doublets.
Isn't it para when it's two doublets?
Correct. And he refused to bring this one. That's what I was strongly expecting him to bring, but I'll still
Oh, so
touch on
then
it.
I'm gonna have the two oxygens para to one another, and then I need to figure out where the rest of my carbons are going.
I don't
Cause
know if you are starting with an oxygen or a carbonate because you can make your ester this way or
um,
you can make it this way. So we really have to
but
decide. I don't think it's gonna be this because we need the oxygen effect.
but can't you not do that because of the IHD?
Why
You know what I mean?
not? We have IHDO5 if I connect it like this.
Okay.
I'm just saying we have to decide the shape of our ester. Do we start with the oxygen or the carbonyl group? I feel you have to start with the carbonyl group somehow. But there's a problem. You do have a singlet, and you also have singlets here. Integration is trying to suggest something. Let's see
So can
what
we
you
just
think.
do
Uh-huh.
just do the ester with like one methyl group? That would give us a singlet.
But what about the CH2? I see the answer, but you are not thinking a little bit far. That's a CH3, this is a
Well,
CH2. Even the CH2 needs to be there at 4.
wait, you're saying the CH2 has to be a singlet?
It shows it as a singlet.
I'm so confused.
Okay, I'll rescue you. I'll help you out. This is one of the bad ones, I know. Um, these are between 4 and 3, but we know we can have double effect, and we also have this guy here at 2. This must be benzylic. It's no other alternative. So maybe our structure looks like this.
Oh, I have an idea. I have an idea.
Yeah, say it.
What if I like I don't know if this is allowed to happen. What if I do my carbonyl, right? And then I like let it go to a CH2 group, but then attach
Where,
my
where
ester to that.
you have your
Is that
carbonyl, then
CH2 there, then ester? Is that allowed to happen?
the ester is the carbonyl itself. Maybe oxygen, then
Yeah.
CH3.
Yeah. Is that allowed to happen? Because that's
That
what
one
I
is
was thinking.
allowed.
But
So
not
maybe
right.
we don't have an ester. Maybe we have this.
Wait, hold on. 6, 7.
That's very allowed because now this helps you to
Yeah.
put.
And then we could do. Oh wait, that's 2 oxygens. Then we can
You just
do.
do a CH3
Like,
down here. That's benzylic hydrogens that will show up at 2. So that
yeah,
is
and then.
one. The other option could be this. The other option could be doing a CH2 benzylic, but it's between 2 electron drawing groups. So it's not going to show up at 2. It's going to show up deshielded to 3.5. And then you do your methyl group. That's the other option. So
I see. Okay.
it's either this or this.
Okay.
I'm leaning more towards your suggestion because of the chemical shift. That's quite deshielded.
Okay.
I don't think you anybody will be denied points if they drew either of those two molecules.
Okay. Because it fills all the things, but
Yeah. Okay. So I think everything else checks with terms of depth. So no issue with that. Mm,
yeah, I think I'm okay.
that one is easy. Let me see this one. So here's the aldehyde one. Let me see if you can do it. Then we do synthesis. How will you analyze that? Is there anything else now?
There's 4 signals. The aldehyde, we know it's there because it's at between 9 and 10.
Yeah,
The one
this. Uh-huh.
between 1 and 2 is a CH3 group.
1 and 2. That's a CH3.
Yeah, I think so. And then I'm gonna
We are
do
were we given integration?
yeah,
We are given relative peak area. Yeah, that is a CH3.
yeah, and then it says 1 and 1 and 1.
So CH.
Okay, I'm gonna do the IHD. Plus
Okay.
1 times 2 plus 2. It's 2. So we'll have 1 for the aldehyde, One oxygen
The
and
other
one.
one is these ones, they are
Oh,
in the alkene region.
okay.
Alkene region is between 5 and 6.5. So you have that and this. Carbono and a C double bond C.
Okay. CH3 to make it a singlet because it'll be. Okay, I think I did it.
All right, so let me suggest mine and see if it matches yours.
Yeah, that's what I did. Because then it would be 1H, and that would give us the singlet.
The
1H.
problem is the CH3 is not a doublet. See this CH3 right here, right now, it will show up as a doublet because n equals to 1. So I will not go with that. Instead, I'm gonna go with this one, where the CH3 has
Mm.
no neighboring hydrogen. You understand my argument?
Yes, I do.
These two, the double bond cannot rotate when we talked about homotopic, diastereotopic, and entropic. These two are different because the hydrogen is gonna see the oxygen. Here, the hydrogen sees the methyl group. That's why
Okay.
they show up different here.
Oh, wait. Hold on.
Those are different hydrogens.
Yeah. Okay.
Double bond does not rotate.
Okay.
Ooh, NMR can be something, but I think that's solved.
Okay.
So
I'm more
here,
afraid of the
huh?
or this.
Yeah, we just hope he doesn't bring crazy ones, but that is a process for sure. You good?
Mm-hmm.
Okay, that was just a quick refresher. We don't know what he will bring, but it's gonna be okay. So now let's just do random stuff. This is where your brain gets cooked more. Just randomly. So you have this. And you did not do Aldo. You went, there's a lot he skipped. I'm gonna do something else. Start small. Mm,
I finished the first one.
okay. How does your product look like?
Do you want me to show you or just like explain it?
Just explain what you have.
I have a butane with a methyl and a hydroxy group on the same carbon because we had the CH3 group come from the Grignard and that also made the ketone or the carbonyl become an alcohol.
Correct. Tertiary alcohol. I'm telling you, you know this. Let's see. Right, number two.
Okay. I did. At least I think I did the second one.
Mm-hmm. What you got?
Are you supposed to get an imine for this one?
You tell me, what did you get as a final?
That's what I got.
You don't get it. Doesn't stop at the I mean.
This is the H0 plus, right? That's where I'm
Yeah,
stuck.
so this is step one.
Yeah. And you
Step
replace the
two,
oxygen
that's a
with
this is a primary amine, so it gives me my imine. Remember the shortcut always helps out.
So is the H0 plus gonna protonate it, or is it going to?
It hydrolyzes it back to the ketone.
That was really sneaky.
Thank you.
So I was gonna say like that it's not gonna do anything.
Because someone will be like, "What? I just made a ketone. Why am I taking it back?"
Yeah, I
Do
don't.
it. Do it.
Okay. Um, I'm like doing the second one or the next one.
You're done with the second one?
So far I reduced it to, or did you say no? I
You
oxidized it
oxidize.
to a carboxylic acid, and then I'm going to make it an acid chloride. So I'm gonna make it a, I'm gonna get rid of the carboxylic acid and get a primary chlorine, I guess, because you have to keep
Now
the
you
carbon.
just keep the carbonyl, you just put a CO.
Oh, okay.
That's the acid chloride.
And then with the CH3NH2, it's gonna attack, kick off the chlorine. It's a good leaving group.
Hmm.
Hold on, I don't know what it's gonna look like.
Just say that is lost. Because we always finish with the D step, remember?
Wait, so is it double bond O
AED. Eh?
two? So is it? I'm like not looking at the screen because I want to see if I got it right. Is it
Okay.
a carbonyl to an NH2? Is that correct?
Carbonyl will get NH2, but nitrogen will be positive. You'll have to deprotonate it.
So is it NH? It wouldn't be NH.
Yeah, it will be NHCH3. Because
NHCH3.
nitrogen home
Oh,
rule,
I forgot the CH3. Okay, I didn't
yeah,
realize.
home rule will tell you that you need to have 3 lines.
Yeah. Okay.
Right? I know, a little challenging, but it works. Try the fourth one. Let me wake up this lady. She needs to go to work. She woke herself up. It's like this man. So this is the secondary amine. Very important to note.
Yeah. So I'm gonna get an enamine. That's basically what'll happen.
Yeah, make sure you count your carbons. And then someone gave you H2PDC. What
So
happens?
I'm gonna get rid of that alkene.
Correct.
Wait,
Your brain is full of information. Don't ever doubt yourself.
wait, for the one that step, aren't you supposed to have two CH3s? Because we had CH3 2, or am I reading that wrong?
Oh yeah,
Like with
we
the
have two CH3s correct here because the hydrogen goes away.
okay.
Correct. You're reading it correctly. It's my assumption. So we end up with a tertiary amine. This is called reductive amination. There's a special reagent for this usually, but I sneaked this one in because it's organic one.
Yeah.
So the best reducing agent for enamines is NABH
Or
B
NaOH
no
that?
BH2 uh,
Oh, so something I haven't learned.
CN, yeah, something of the sort, or BHCN2, something like that. It's a sodium borohydride that has a CN that works for this. There's gonna be a thunderstorm coming in an hour. I
Oh,
hope
really?
we don't lose power. Yeah. Okay. So you're good with this, right?
Yeah.
I'm building you up towards more challenging ones. So
Okay.
just wake up your brain as we go.
I think I'm most nervous about like identifying reagents because I feel like a lot of them are just like the same. Like for major products questions. Like you could do a lot with H3O plus, you know what I mean?
Yes, HTO plus is almost everywhere for sure. No, let's just do those two. I wouldn't want to add HTO plus to this. Things will go wrong.
Um so with this one I have a question. Am
Mhm.
I gonna do the aldehyde or the ketone? I know that the aldehyde's more reactive.
Thank
So
you.
does that
So that's
that's
the
the
one that needs to be protected. The more reactive one always reacts first with whichever.
oh, and then the Vidig or whatever it's called is
Yeah,
gonna deal with the ketone,
thank you. And then you
get rid of the
stop there for this
oxygen
one.
CH2. That'll be a CH2, and then okay,
You're just adding a CH2 somewhere. Uh-huh.
okay,
So follow the process.
okay. I got it. I think I got it right. I don't know. So it's a CH2. Did you sneak in a synthesis?
Yeah, we are building towards those. We're going to make spice some things up as we go.
I'm not very happy about that, but I need
I
it.
know, I know.
I got the one for the last predict the products. Um,
Okay, so you should make sure again, don't lose your carbons because
yeah,
you're actually adding CH2 there. If you want, you don't show
yeah,
the CH2. That one
Okay.
stays like that. The reason why I did not want to put H2O plus here,
It would remove that, and
if
then
I
yeah,
do H2O plus,
it goes back to
there's
the alpha.
gonna be an organic one problem.
I see.
And this one will not stop. This
Yeah.
will attack this carbon one, two, three, four. That's a four-member ring. Maybe it will not because four-member
Oh,
rings
so
are straight.
the H3O plus would also break
The
that.
double bond by
Okay.
Markovnikov addition, yeah, and also remove the protecting group.
Okay.
So usually we don't go crazy with that when we realize in the problem that H2O plus can do a mess.
I have
Uh,
no idea where to start with the next one. Like I have no idea.
who reacted?
The ketone's more reactive than the ester. I know that. The ketone has to get protected. Is that correct? And then we'll deal with the other one. No.
Yeah, let's protect the ketone then.
Is that right? Or
Yeah, you start with protection, then what?
um, I don't know. Hold on. Let me look on. I mean, like, can I like? Oh wait, that's how that works. I want to use something that will get rid of the ketone, but I feel like I need to deal with like the whole thing. I don't know what to do. Is it simple and
How
I'm
do you
making?
convert an ester to an alcohol, my friend?
Can I just use LiAlH4?
Yeah,
HCl plus, I think it is.
just anytime you're stranded, don't look at the molecule as a whole. Do something, write out a step.
Okay.
Then you will know how to solve the other issues later.
Okay.
You know that ethers are not reactive, so you need to revert this back to this. What do you do?
I need to get it back to that.
Yeah, you would
Oh,
hide,
oh.
you just hydrolyze it, let it go away. And then there's a reaction that gets rid of the carbonyl entirely to give you two hydrogens.
Don't tell me what it is. I know what it is. Do I know what it is?
You know, you know actually,
Can I use Clemenson?
Clemenzine is usually good for the benzylic carbonyls, but you will not be penalized if you suggest it. There's the other one starting with a W. We did the
Oh,
mechanism.
the
It
I could
sounds
use
like an animal.
I could what? Wolf Keister?
Yes,
Okay.
you know how to do this. I told you. This
Can
one
I do
can
fun?
otherwise be written as N2, N2, NH2, NH2, I believe, and then KOH. I think there's some heating. That
Yeah.
is the Wolf-Kishner.
Wait, so it's KO.
I believe we need hydrazine and KOH. I don't think there's an acidic workup.
It was like heat too or something. Like this is what I mean. The textbook doesn't say like this is the reagent. Like it just kind of is like here's the mechanism. Have fun. Like, but what?
Yeah.
I think that's why I'm so stressed out because I feel like I'm not going to be able to identify what's going on.
Yeah, it's N2H4KOH or trace acid, usually with heating. So what I gave you is correct.
Wait, you said without heating?
With,
Okay, I was gonna say I thought it did have heat.
yeah. So the problem you are scared about is very doable. It's just that like you said, the reagents. Remembering the reagents
It's too much.
is too much. I know, but when you talk to your
Um,
mom, you tell your mom, "Mommy, please encourage me." I don't want to give up. Okay, let's come back to this. See what you would tell me about this. Yeah, let's just do those two steps.
My hand like won't even draw or go anymore.
Your hand is tired.
Yeah, like you should see when my hexagon is going.
Your handwriting is gone.
Disgusting, and I can't do it. Um, the PCC will make the alcohol a ketone, and then the RCO3H will. There's gonna be like it's gonna like split, and we're gonna put an oxygen in between. And I know
Which
that
side?
this is what I'm confused about because I know that the secondary and the phenyl are equal to each other.
Is
Correct.
that a
I
secondary? This is a primary.
That's primary. Okay, then I'm stupid. It goes near the phenyl then.
Yes.
Okay.
So that's the name for that reaction was Bayer Villager
Yeah, I remember that one.
oxidation. Don't forget.
Okay.
I usually call it the BV reaction. Phenol has a higher migratory aptitude tendency.
Yeah. Okay.
Okay.
I'm like so scared. Like the
Mm,
thought of taking the test like actually makes me want to throw up.
you'll be fine.
I don't think so.
Let's see. I don't want to go with that for now. I'll do that later.
So with the like Wittig or whatever with the BULI, I know those two go together. Does that just mean I'm putting like a butane on? You know what I mean?
You
Because like
you
I
will
have
lose the BU.
what is
That is
BU?
just a strong base. A
Oh,
B
so this like carbonyl situation is gonna go here in place.
is gonna replace the bromine
Okay, got it.
technically.
Okay.
So I started off from the starting point because sometimes we don't give you the yield. Sometimes, many times we don't give you the yield. We want to make sure that you know how it's made. And this is where we use the bully. He does that. He does just that. He's a
Oh,
bully.
so it's kind of like getting the Grignard prepared. Like
Yeah,
they make it.
it's kind of the same similar thing. And then these can have its resonance, and then from here you can do the shortcut.
Is that the answer?
No,
Oh,
did you get your answer already? You'll have
yeah.
to lose that.
Hold on, I did it wrong.
You'll have to lose that to see the answer, and it has to be a Z because this is an unstabilized yield.
It's one,
This
two,
is the
three.
answer
Okay. My iPad is actually like almost 90 now. One, two, three.
because this is unstabilized. wonder how many qualities I need. I think there are only two. So this one is the one that's gonna give you the opposite.
Yeah, the E confirmation because of the double bond O, right? Is that a double bond O?
Yeah, that's a that one. Oh, like you have lost my handwriting because of writing too much. I always lose it in the by evening. I mean,
So I'm confused
mm,
because like I understand like what gets lost, but what do I do with this like carbonyl that's there? Or that's not even a carbonyl because there's no carbon, but the double bond O, because like normally you like circle what gets
yeah,
lost, but
this
I
one
don't.
you will not circulate. Just a moment, I'm not done writing it. I want to trap it somehow. I want to make it stabilized by an carbonyl. I'm looking to see where I put my carbonyl. Somewhere there is fine. Yeah. Mm, yeah, now this is stabilized. And we'll assume that we have our negative charge here. So here the shortcut is not as we did before. You just assume that you're losing all this.
Yeah.
Because normally we lose the P, PH3, whatever. You can take it as a similar thing because you're losing the P something and the oxygen. And you have to have the E alkene because the other one gave us the Z. Imagine this is just that one chapter. We have not touched on the carboxylic acid ones. Maybe you can do that tomorrow. Are we meeting tomorrow?
I don't think so, but we can
When is your exam?
Wednesday.
Mm, well, you let me know.
Whatever you think, honestly, because I
I
feel
don't
like
know
I know.
how far you're done with chapter 20.
I'll know by like the end of tomorrow, because we're going over it in lecture.
You have class tomorrow,
Yeah.
and then that's when you'll know how far you're going or what.
Yeah.
You think he's gonna start the amine chapter?
He better not. Over this.
This is the E alkene that I would get. The ester has to be there.
Wait. I thought. Never mind.
Only the circled part is lost. So this carbon where the negative charge is, all the way out, you have to keep that here.
Oh my god, I'm being so stupid right now. I literally had that, and for some reason in my head, I like thought it was the Z confirmation, and it's literally
Mhm.
E.
So if you show your hydrogen, you see this priority 2, priority 1, priority, priority 2, priority 1. It has to be an E.
Okay.
Yeah. Okay. And then let's just do one more here and see what you will get. I'll not touch on the official um,
Okay.
synthesis today. We might do that next time we meet. We should do
We
that
could
next time.
we could just do it tomorrow because I know like if I do it the night before the exam, I'm gonna be way too stressed out. So I
Gonna be
think
panicked.
tomorrow's better, and then Tuesday we can just do a final review like we usually do.
All right.
Because
I'll
I'm
put an hour
scared.
tomorrow. We see.
Yes, it's perfect.
What time are you available tomorrow as you do that?
5, 6, 7.
Let's do 7 p.m. your time. That's then. And if I forget, you will text me,
Yeah,
inbox me.
yeah, that sounds good.
Okay.
I'm stuck a little bit.
Oh no, don't be stuck. It's doable.
I'm stuck with the LIALH4 because I know it does something to the NH2 and I can't put my finger on it.
So this is what's happening. I'm assuming you went to the carboxylic acid.
Yeah, and then the acid chloride. And then I added the CH3N2, and that's where I'm stuck because I know that the LIALH4 does something special with it and I can't remember it.
So we said before that you're losing one hydrogen.
Yeah, and then you get the CH3 off of it.
And the
Wait,
last time where we stopped, I think, in that chapter was reduction of nitriles and amides. We said the carbonyl, the
back.
carbon, huh?
Am I just gonna go back to the carboxylic acid?
No, the carbonyl entirely disappears.
Okay.
Right? That's what we said, that if you have a nitrile,
Yeah, because like normally it would get rid of it and give
yeah,
you the alpha. So I just
normally,
know it has to go away.
yeah,
Okay.
this is not an ester. This is an amide. So when you're dealing with an amide, just get rid of the carbonyl.
That just drove me insane because I knew it did something, but
Yeah.
I couldn't figure it out.
Now with that two, these tools, now chapter 19 should be manageable. Then because the last problem I mixed